For those of you who are joining early, welcome to the MachineMetrics webinar series, Buyer's Guide to Industrial IoT Platforms. Welcome and hang in there. We'll be getting started in just a few minutes. And for those of you who have already joined early, welcome to the MachineMetrics webinar series, Buyer's Guide to Industrial IoT Platforms. Sit tight and we'll be getting started in just a few minutes as everybody logs in. Hello, everybody, and welcome to the MachineMetrics webinar series, Buyer's Guide to Industrial IoT Platforms. We're just at the top of the hour, but we've got a number of people logging in right now, so we're just going to give it 1 or 2 more minutes, and then we will get started immediately. So sit tight. Okay, well, we still have people coming in, but we're going to get started. So firstly, welcome everybody to the MachineMetrics webinar series, Buyer's Guide to Industrial IoT Platforms. We are excited to have you with us today. A brief abstract on what we're going to be talking about today. The industrial Internet of Things is a hot space right now, as many of you are aware, with manufacturing really representing perhaps the largest greenfield opportunity yet for digitization. Yet, IoT platform implementations have had historically high rates of failure within the vertical. What's contributing to these failures? What needs to change? In this webinar, we're going to examine common approaches for enabling industrial IoT initiatives. We're going to define some terms, some of the pros and cons of each approach, and their culpability for certain high levels of failure. Then we're going to also introduce a new approach that's already driving rapid and continuous value creation for manufacturers and the companies that provide service to their manufacturing assets. So welcome and thanks for joining us today. I am, as always, your host and moderator, Graham Immerman, I'm thankful to have you all here. We have a very special guest, somebody I work with very often, and we're lucky to have him providing this presentation, Dave Westrom, our VP of Business Development. Dave, thanks for being here. Give everybody a wave. Really appreciate that. A couple quick housekeeping items and get it all out of the way, but we're still running our COVID-19 response program. We designed this program to provide free access to the MachineMetrics platform for manufacturers, providing support to those hospitals and medical device productions required so people can treat the pandemic that we're all entrenched in today. An update on what's coming next. In just a few weeks, our ever popular State of the Industry Impact of COVID on Manufacturing August update will be happening August 25th at 1 to 2. We'll be joined by Jerry Foster, who's the CTO of Plex, as well as Chad Moutre of NAM, and we're going to be providing a data-driven update on what we're seeing within the data and how it's impacting the industry that we all work within. The last item before we get started, I figure that we always try to give you just a brief rundown on who we are at MachineMetrics. Many of you already know us, but for those of you that don't, MachineMetrics is an industrial IoT platform for machines. MachineMetrics' goal is to accelerate industrial transformation by providing an intuitive and flexible platform to easily collect and transform data from any piece of manufacturing equipment into powerful, actionable apps that reduce machine downtime, optimize your capacity, drive increased throughput and profitability for factories. Right now, we do have hundreds of manufacturers connecting thousands of machines to MachineMetrics across their global factories. And our platform is allowing these companies to harness the data from their machines so they can deliver the right information to the right people at the right time to improve their productivity and ultimately remain globally competitive. Just a little bit, we know that most shop floor digital transformation initiatives are stifled by an inability to get usable data. And that leads to all sorts of operational inefficiencies that affect every component of the business. So our Edge platform allows us to create a foundation with the automatic data capture and transformation of machine data to harness it so you can immediately drive digital factory transformation. Our Edge platform does feature plug and play connectivity with machines, featuring PLCs, digital and analog I/O, and sensors. So you can take all that data, transform immediately into a standard structure across your entire fleet and factories. That capability enables consumable data instantly. At the cloud level, that data is securely and instantly streamed where via Ethernet, Wi-Fi, or cellular, where our platform ingests it. That our unique cloud platform has an infrastructure designed specifically for machine data to enable instant analytics and insights, including machine performance, condition monitoring, and reporting, as well as eminent extensibility through APIs and BI integrations to every other systems. Lastly, our out-of-the-box apps deliver use cases that drive immediate value and actionability on that data, from real-time dashboards and historical reporting to rules-based workflows to text and email notifications that deliver optimized processes to factory workers. You can build your own apps. You can seamlessly connect with your current shop floor systems to integrate that machine data across your digital factory. Again, at MachineMetrics, our objective is to significantly expedite the time to value for IoT and Industry 4.0 initiatives, so manufacturers can put your data to work immediately and provide a foundation for scaling industrial IoT across your operations while prioritizing your resources towards what you do best, which is make things. Now, with that, I want to pass the mic to Dave, who's going to provide us a presentation today, which I'm personally very excited for. Dave, take it away.
Thanks, Graham. So according to Cisco, 76% of industrial IoT implementations fail. And, you know, in addition to that, despite manufacturing being the largest industry in the United States and producing the most raw data, it actually has the least amount of digitization. Only 5% of the processes roughly are digitized. And next slide. Why such a high rate of failure? Especially, you know, again, considering that digitization of machine assets is so important to driving successful IoT implementations, unlocking the insights from those assets. We believe that failure figure quoted by Cisco is really rooted in the following. One, friction introduced through the processes, technologies, and products that are used to enable and sustain these industrial IoT initiatives, which results in too much time to achieve initial value. That is probably the major problem. Secondly, just the inability to innovate and drive continuous improvement through the life cycle of the initiative. And lastly, misalignment of resources from the various participants in the solution ecosystem. And I'm going to touch on each of these throughout the presentation. So next slide. Just a few terms and definitions. We define the Internet of Things as the confluence of things, which includes machines, devices, people, and systems. And next. And at MachineMetrics, we define a platform as a set of technologies and tools that can be leveraged to create the applications and solutions that drive the initiatives. Okay, next slide. So the challenge of discrete manufacturing, there are many challenges. And just touch on each of these briefly. The data variety. Not only are there many distinct types of equipment, you know, lathes, mills, plastic injection molding, stamping, laser cutters, robots. There's many different types of machine assets in discrete manufacturing facilities. Depending on the mechanisms available for acquiring data from those systems, these data points can be very diverse. And to provide effective tools for analyzing the data across these systems, the data has to be transformed in a way that it's consumable. So it essentially has to be converted into a common data model, contextualized so that it can be consumed and absorbed. And you know, not only that, but the variables grow from there, because each of the machines often has its own control system and its own mechanism for gathering data. So the data can differ by the family, the make, the model of the machine, using the control, as well as the version of software running on that control. And then some of the machines, older machines, may not even have a control system. So there's that challenge, and plants that regardless of what type of machine they have, the variety, the numbers, the variables, they want a consistent user experience across their plants. Data volume. The equipment is complex. The machine is essentially a large system of components that works in coordination, resulting in hundreds of distinct data points that change constantly. And depending on the application, there may be a range of different data rates that are required. It could be ranging from 10 hertz to 100 kilohertz. So platforms consuming this range of data, you've got to be able to analyze the data at multiple levels within the system to avoid sending and storing unnecessary data when only the aggregate or computed result is sufficient. So there's a wide range of requirements around data volume. Data speed, again, a range of requirements there. Some systems provide value in low fidelity and a high latency. Other IoT use cases require much more real-time data to be effective. The number of disparate systems in the plant, ranging from ERP, MES, SPC, CMMS, BI, and it goes on from there. These are different silos of data that are required to be interconnected to deliver truly actionable insights. So integrating these legacy systems can be a complex task. Having robust data models for each application serving the vertical is required to adequately capture events as well. And then the IT infrastructure. Their highly elastic and scalable systems are sort of a new entrant to manufacturers and their IT organizations. There are different processing and storage requirements for industrial Internet of Things. And in some cases, it can be prohibitively costly to over provision a system for peak loads at all times. So these are all variables that have to be managed and add to the complexity of the challenge. So next. So when we look at the options for enabling industrial IoT initiatives, traditionally the choices are do it yourself. Build your own system, build your own solution from the ground up. There are the horizontal IoT platforms. Those typically have to be supplemented in some degree by do-it-yourself, and I'll get into that during the presentation. And then there are what I would call the traditional packaged apps and packaged applications and software solutions. There's pros and cons to each of these approaches, and that's illustrated somewhat on the graph to the right. And you can go to the next slide. So with a horizontal IoT platform, you can pretty much create whatever you want. So pros obviously is innovation, which I define as the ability to create new business processes. With an IoT, a horizontal IoT platform, you model out your process, your material flow. You'll typically use some sort of packaged connector to connect to a machine. But again, you've got to learn how to use these tools. In some cases, they're costly. But when I mentioned earlier that there's also a DIY component to this, there's the gap in between where you create the model and where you connect to the machine, and that is the transformation of the data, the contextualization of the data. And in most cases, that has to be coded. So that has to be built, and in many cases, it's the manufacturer that ends up having to build that out, and that creates friction in the process. It takes time and it's costly. On the other hand, just in building that and the time, that impacts how quickly you can drive initial value from the investment. Often that can be months, if not longer, to build out that missing piece. On the other end, the packaged applications out of the box provide some level of capability in the application, which will, depending on your particular business and your business drivers, will allow you to generate some immediate value. The challenge with a packaged application is really back on that innovation end, is beyond the ability to leverage that application, the ability to extend it, to add value to it, to build on top of it, is often a challenge. The other disadvantage is that the customer is really forced to adapt their processes to conform to that particular software or that particular application. So, that may be effective as a means to automate a process. It limits the ability of the manufacturer to differentiate themselves and, again, to innovate, to create new processes. And then the DIY, when you build from scratch, the time is even more prohibitive. The cost to sustain is huge in most cases, and there's also a question of are those the best use of resources? And I'll get into that as we go on. You can go to the next one. So MachineMetrics, we provide what we consider to be a hybrid approach, and it's really it really provides the best of both worlds. So we accelerate digitization in manufacturing and really eliminate the causes of these failed initiatives. So by automating the collection and transformation of real-time machine data, augmented with data from people, other devices, and systems, we provide descriptive, diagnostic, prescriptive analytics through packaged SaaS applications. And that provides immediate value for our customers. So in addition to a platform that's extensible through open APIs, through our connection to best-of-breed factory applications, we're able to allow our partners and our customers to add their own IP, their own value add on top of our platform, but also take advantage of prepackaged applications that come out of the box, dashboards, reports, capabilities that provide immediate value with consumable data. We've automated that data transformation process so that literally within minutes, our customers can connect to their machines and have usable data and insights through those prepackaged applications, reports, dashboards that I mentioned. This enables rapid time to value. It also really triggers a never-ending continuous improvement process. So it allows our customers to initially focus on the low-hanging fruit, areas where they can drive immediate value. But at the same time, the insights from the data allow them to prioritize their initiatives and really drive ensuing initiatives. And that process continues through time. So the goal is to ensure that customers continuously drive more value out of their investment in MachineMetrics. The implementation being friction-free, over 80% of our implementations now are done by our manufacturers, our manufacturing customers. So especially in this time of COVID, we're not forced to send people to plants to enable implementations. We can send our edge device to a customer, they can hook it up, and because we've automated that data transformation component that I mentioned earlier, literally within minutes, they have consumable data and insights. This reduces the costs, and this model also sets the customer up so that with our cloud-based approach, sustaining the system is inexpensive, and the customer continues to benefit and grow over time. Next slide. So what steps can manufacturers take to ensure success? And we'll cover each of these one at a time. I believe the next slide goes to the first, which is really leveraging domain expertise. And this is we believe that manufacturers are the process experts. Our manufacturing customers know more about their processes than anyone else, and that obviously includes us. So providing manufacturers with the tools to allow them to focus on optimizing their processes and creating new processes, that we believe is an optimal model. And taking away the infrastructure and the plumbing pieces that we believe we have essentially perfected and automated, taking that off the plate allows our customers to really focus on what they do best. We also work with machine builders. Many of our machine builder partners and their distributors will embed MachineMetrics in their machines. And again, these companies know their machines better than anyone else. So once again, being able to focus on optimizing their machines creates an ideal situation. Whereas in the past, machine builders in some cases have attempted to create their own platforms, their own machine monitoring offerings. The challenge there is that because of the wide range of machines and plants and the wide range of data requirements that I mentioned earlier, we don't see many manufacturers that are willing to buy a machine monitoring or IoT platform from a machine builder and put it on another machine builder's machine. And because they want a common experience across the whole plant, it really makes it prohibitive to be in that business for those companies. So working with them once again to allow them and enable them to focus on what they do best, and then MachineMetrics, we stay focused on the things where we believe we provide the most value. So next slide, please. So don't reinvent the wheel. And this is focused on that data transformation component that I mentioned earlier. And and some of this covers the point I made earlier, but not to underline how complex this is and what the costs are for trying to develop especially for larger companies that have multiple plants and hundreds of different machines and machine types, the cost to connect to these machines and then contextualize the data, the problem becomes exponential as the number of machines increase. And when you consider, you can go to the next slide, please. See if we get there. Yeah, so this slide illustrates, once again, some of the variables. It shows our edge device, number of protocols. There's obviously many protocols, many machines, many different control systems. We have, as I mentioned earlier, connected to hundreds of different types of machines, and some machines don't have a control system. So we have different ways of connecting. If a machine doesn't have a control system, we'll connect to digital inputs or analog sensors. But when you look at this, the complexity and the number of variables around the plant, and the idea of building not only the connectors, but writing the code to transform and contextualize the data across all of these different machines with all of these different variables is a daunting task. And with MachineMetrics, we've done this in software, all on a single edge device. So if you go to the next slide, is a rough attempt to illustrate this. This is six machines, but it could be 50 machines or hundreds of machines. We typically we can network up to 50 machines to one edge device. So imagine 50 different machines, each a different brand, a different make, a different model, with a different control system, with a different protocol, with some of the machines not having a control system because they're older and require a different way to connect. We're connecting to all of those machines with a single low-cost edge device. And it's done automatically. So when I say don't try this at home, this is literally sending a device such as this to a plant with this number of different machines and different variables, and literally hooking them up in, again, depending on the range in hours, and having consumable data through reports and dashboards, and customers that are ready to immediately focus on driving value in their operations, instead of spending 6 months, a year, however long, figuring out how to connect to those machines and write the code. You can go to the next slide. And many of our customers have attempted this in the past and have found that not only is it costly to attempt this and to develop this, it requires large teams to develop the code. And as I mentioned earlier, the problem becomes exponential as you add more and more machines. Why? Because you got to now sustain that, right? When you want to make changes to the software, how do you do that? If sustaining the software, if the software changes, if the control system changes, if the analytics change, if you have to connect to other data systems in the enterprise, once again, the software may have to evolve and change. So for customers who do not possess connectivity and data transformation as a core competence, it's a huge cost, but it's also honestly a misallocation of resources. So for MachineMetrics, the process of sustaining and evolving our platform has been optimized and, as I mentioned earlier, really automated around this piece. So it's provided as part of our service, and it's transparent to our customers. And so even if customers that choose a horizontal IoT platform or attempt to pigeonhole an MES or work instruction platform to enable consumable data from discrete manufacturing assets, the friction and the results are going to be similar. A lot of these tools, again, you can model your process. You may have connectors to different machines, but the challenge of transforming that data and making it consumable for the various constituents and systems across your organization is going to remain. And this can be a painstaking process that may require months, if not years, of work to develop and sustain. So next slide, please. So fortunately, manufacturers can easily determine whether any claim of a friction-free experience is valid. And it's really through these questions. Can your vendor or your internal organization, for that matter, can they connect to plant assets, produce transformed consumable data, and provide applications that drive immediate value in under 24 hours? Can they do so without entering your plant, without sending people to your plant? Can they enable their solution by, remotely coaching your resources through a simple process? Can the applications and the underlying infrastructure be sustained remotely with zero investment from the manufacturer? I mean, these are the kinds of questions that should be asked, and the things that should be a thought of when evaluating options for industrial IoT initiatives. Next slide. So coming back to the topic of focus and the ecosystem. The industrial IoT ecosystem consists of multiple players: manufacturers, machine builders, their distributors, the service providers, the technology and solution providers, system integrators, consultants, software providers. Each has their own unique capability, expertise, and intellectual property that can be leveraged to drive a successful industrial IoT initiative. And not just to drive it, but to drive it rapidly. And, when these resources are misaligned or sub-optimized, the initiatives often come up short in delivering on the promised value proposition, or they fail altogether, as those statistics earlier show. So at MachineMetrics, our focus is really on leveraging the capabilities of that broad ecosystem and the knowledge, the core competence, the things that those participants do best, so that we can accelerate the processes as quickly as possible. Next. So when we engage our manufacturing customers and work with our partners, as I mentioned earlier, because we're able to rapidly connect, provide consumable data that's transformed, and we do that through packaged applications, prepackaged dashboards, reports. We're able to immediately focus on the low-hanging fruit, the initial initiatives. Where can we drive the most value the quickest with our customers? We're able to baseline performance. Many of our customers start out before MachineMetrics. They've captured data manually, and often there's a certain perception of where key metrics are, such as utilization. Once they implement MachineMetrics and they're capturing real-time data, they find that that perception is lower than what the actual metric is. So they're able to get a good baseline and then focus on the areas that the insights from the data will point them in the right direction for where they can generate value the quickest. So for example, our customers that are, I would say, low mix, high volume, capacity constrained manufacturers will typically see a big bump in utilization very quickly just from having better visibility into their processes. So we can work with our customer to achieve that value quickly, and then again use the data and the insights to determine and prioritize what subsequent initiatives should be, and then really trigger that that overall continuous improvement process. So, and as we go throughout that, we're able to measure that value for our customers. We put a process in place so our customers can measure that. Our customers will often work with consultants or other partners, and that data infrastructure will provide the foundation to drive that. Next. So just a couple of comments on some future thoughts and direction, and then we can open it up for questions. I really see that based on interaction with our partner ecosystem globally and our customers, that we're in the early stages of uncovering opportunities to leverage machine data and insights from machine operation, from machine assets combined with operational data to drive value for customers. And we have customers that are on a daily basis coming up with new innovative processes where they're leveraging machine data in combination with other systems and other groups within the organization to drive value. So for example, working with the financial part of the organization to look at investment opportunities in plants or across the enterprise. What machines should be sunsetted or replaced? What new investments are required in machines? How do you make those decisions? Are you able to have a clear window into your capacity requirements and your costs around your machine assets, and leverage that data to make those decisions? Or is it simply just a request from the plant that says, hey, we think we need a new asset, but there's no hard data to back that up. Leveraging data into HR processes. We're seeing a lot of interesting things there, and HR systems to determine performance, to enable performance reviews. Visibility into the machines, the operators, other participants in the plants provides a lot of insights into performance. Enabling the vision of systems like CMMS systems, ERP systems, MES systems. We have customers that have made significant investments in CMMS maintenance systems, but they're still maintaining the equipment based on a set schedule. If you don't know how long the machine's been running, what the load on the machine is, other data points, it's hard to change those processes. So these are just a few of many examples where data is being leveraged to really drive innovation in a number of areas. And again, I think we're in the early innings of that. The other area that's of extreme interest is around, I mentioned earlier the data frequencies, the leveraging high frequency data to enable predictive analytics. We've made significant progress in being able to leverage high frequency data to predict tool wear and tool failure. And we're seeing some huge opportunities here as well, but also to provide that infrastructure to enable our partners and our customers to develop their own algorithms and their own analytics to solve different problems. So again, it comes back to alignment of that ecosystem and leveraging what our partners and our customers do best, so that we can drive the most value the fastest. I'm going to stop there and turn it back over to Graham, and we can open it up for Q&A.
Okay, that was awesome, Dave. Oh, looks like I moved my desk up a little bit since we last chatted. No, that was awesome. Really enjoyed the presentation. I love the concept of aligned value of ecosystems and, focusing on everyone, what they do best. It's something that's resonated a lot with me personally. We did have a number of questions come in, so we're going to address those now. Again, if you do have any questions, please feel free to use the Q&A section of the Zoom navigation, and we'll take those on. But just to start, we've got a number of questions I'm just going to address directly. Some of them I'll send over Dave's way. Dave, it was mentioned, this is a question from a non-attendee, that 76% of IoT cases fail. Could it be because the expectations of the project were not well understood from an ROI or value perspective?
Yeah, absolutely. Again, I think that going into any initiative, there have to be specific objectives. What problems are you trying to solve? What part of the business are you trying to drive improvements in? And then understanding that there's different types of businesses and different business objectives. The challenges that a high mix discrete manufacturing plant that has lower volumes are going to face compared to a high volume low mix, we found that they're pretty dramatic. They're different areas of focus. Companies that make a high mix of parts often are going to be more focused on optimizing their job standards and their cycle times. And, that's a different emphasis and focus. And again, our focus is on making sure we understand where can the most value be driven the quickest, and we start with that, so that the investment can be quickly justified, and then over time, the customer can continue to innovate and drive new value.
Makes a lot of sense. I was talking to some people at McKinsey earlier who were just saying that one of the top disablers they see for industrial IoT projects is just that inability to create that rapid value. And then, projects start to lose steam when people are looking for, ROI. So you have to be able to show that quickly, but it's not just ROI, it's, continuing return and value. So appreciate the response on that, Dave. A couple questions I'll just answer directly. We've got a number of questions about security. One, we'd mentioned that we have security on the edge device. And somebody else asked whether our edge devices are developed in-house. Just a bit about the way that we take that on. We do use a custom off-the-shelf edge device. We've enabled it to have the horsepower and the security capabilities to support our customers. Our edge platform can also run on any other edge device with the necessary computing horsepower or even a local PC-driven virtual machine. I think that's more important to note. The proprietary nature of our system is in the edge platform itself. As David mentioned, we largely gather data directly from the control of the machine to bypass the need for additional sensors. So that enables us to avoid complications like involved with installing sensor-based installs, but also to provide a scalable solution that can be self-installed by our customers. You can also add sensors, as we said, to the system as well. Our edge platform features dozens of custom software adapters that automatically map out, unlock, and standardize those available data points from the control to provide as a plug-and-play solution, because again, Dave was very focused on friction reduction, which I think is key to this presentation. We often will provide our platform running on an inexpensive hardware device that our customers will call the little green box. As we said, we have delivered some customizations to that, such as adding cellular capabilities and additional horsepower. But this device in and of itself is actually impenetrable. Two network interfaces are built into the device. The edge device only requests and pushes data. Nothing can communicate directly or send data directly to the edge device. So software updates are posted to a secure location in our virtual private multi-tenant cloud. And then the edge device gets those updates through a secure VPN. So just wanted to update those, because we got a number of questions about security. I hope that Dave,
just
go
to
ahead.
add one other thing on that too, Graham, is that we don't view ourselves from a strategic standpoint as being in the hardware business. Our whole emphasis is on keeping the hardware cost as low as possible and making that not be an issue for our customers. So that example I gave and talked about with 50 machines with different different types of machines, different ages, vintages, control systems, protocols, et cetera, all being connected to one edge device. I mean, imagine if you had to have had a different edge device customized for each one of those machines, right? So our whole thing is to keep that cost down. We don't make money off the hardware. We do it in the software. That's where the magic is. And that's really key to our philosophy.
Yeah, totally agree, Dave. More questions. It's cool. We have a group that's super interested in the edge because we also see that being, something that's, imperative for the future as of your factory stack along with the cloud. But one of the questions that came in was the maximum frequency of data that can be collected from multiple machines. And what's interesting is that, until recently, for many companies in the edge space, that was much lower. In 2020, actually, our data science team launched a program focused on the application of high frequency machine data for predictive maintenance. The goal essentially was to accelerate predictive analytics use cases for machine tools. And our team, as far as we know, the only company in the world that's solved this, has discovered a way to collect data at 1 kilohertz directly from the control of certain CNC machines without using sensors that can immediately be used as time series or machine data learning model inputs. So you can predict certain failures. And this is a breakthrough that our team has made. Again, as Dave said, we're very platform focused, right? So our objective is to, focus on the ability to collect and transform data from manufacturing equipment to make it most usable. And in that platform vision, right, the ability to enable predictive maintenance, for example, requires a higher sampling rate and a higher fidelity for data to exist in order to achieve some of those use cases. And what we're seeing today with that higher frequency level is, use cases that really have, most manufacturers have only kind of dreamed of, such as, enhanced machine diagnostics, optimizing tools to, be able to visualize increase in tool wears in different materials, environments, so now you can optimize the use of those tools. Also, the ability to visualize quality and quality optimization we have the ability to collect data in real time on tool chatter and detect and predict when parts are going out of spec before they need to be scrapped, right? Or when parts will soon be out of spec, right? And the one that I know that we're getting the most traction on, it sounds like, from our customers are, the ability to detect those initial stress fractures that are occurring into tools and alert the operator or even stop the machine, right, before the problem crashes and breaks the tool or the spindle running. So that predictive maintenance use case, which is something that I think most companies have kind of only dreamed about, something that we're actually enabling today for customers. We are getting a number of other questions, so I'm going to try to take those on as fast as we can. You have custom adapters for Haas, Fanuc, Heidenhain, Siemens. For other machine controls, do you develop or procure? Great question. Is that something that customers should do themselves? No. We don't believe that you should have to build your own adapters for machines. So there are certain machines, we've connected to, and I think Dave and I were compiling this list, literally hundreds and hundreds of different types of machines, right? And any machine essentially that supports, like you said, Haas, Fanuc, Heidenhain, Siemens, MT Connect, Focus, Umadi, OPC-UA, Modbus, etc. What our system does is we leverage those native adapters, but we have our own custom adapter that plugs in and standardizes that data from each of those various control types and adapter types to one standard across all different machines. That standard is modeled after the MT Connect standard, but we don't believe that you should have to waste your time mapping out data points on machine controls. We find that that's a huge decelerant for projects, and I think Dave would highly agree with that statement. Anything else on that point, Dave?
Yeah, no, I think that's correct, and we've developed so many of these that we essentially have an engine, a process internally where if we come across something that we don't have, we can typically create it very, very quickly. I mean, the experience we have internally in doing this and connecting to machines and the process for not only building out a connector, but transforming that data, it's happened so many times. So if a machine that we have not connected to, something that's new, we can typically bang that out very rapidly. And we do that all the time. So what was shown on those slides is just a representative example of what we're capable of doing. Was put there more to just show the number of variables and the complexity again, I think more companies now are coming to the realization that it's not something that makes a lot of sense to attempt to do. I could go through the hundreds of man years that MachineMetrics has in developing this, and just when I came here, I've been with a company for going on 2 years now, but it was the thing that most impressed me about this company was the deep focus on these kinds of assets and the ability to, from really the ground up, to have all this automated and then pulling in something new. It's been done so many times that it's straightforward for anything that we encounter. Customers that have new types of machines or machines we haven't tied into in the past. And by the way, that's happening more and more often. I mean, we have customers that are now deploying MachineMetrics across their enterprise, and they'll come to us with, some machine we never even heard of, and it's like, hey, we want to connect to this. We, again, they're able to do most of it themselves. We enable it, and boom, they're able to add that to their base of assets.
Yeah, totally agreed. Great question that came in here in the chat was, Dave, I know we had mentioned that, our customers, are, 80%, right, able to, self-install MachineMetrics. I think, the question was, and this is a totally legitimate one, and I think I think the interpretation of this, may have led to the question. I think that we can all agree that oftentimes when all the work is kind of like laid to rest on the manufacturer, right? This is where friction tends to occur, right? But in this case, you know, to the question that's asked, you know, because the system that we have is plug and play, the actual installation and the ability to collect and transform that data is quite literally a plug and play scenario. And this, I think, you know, Dave, you can correct me if I'm wrong, but this was a really great use case actually that we saw for some of our customers who, you know, wanted to test the boundaries of what could be connected through our system. You know, we have a very simple scripting interface that allows customers to connect even the most complex equipment that doesn't have a PLC or a control. And we have customers today that are, you know, doing that themselves and connecting, you know, manual welders, you know, paint lines, shaking machines, you know, all sorts of different devices. And, you know, the truth is, when you're at a facility, you don't just have a couple different pieces of equipment. Sometimes you do, and that's great. And many times that's very easy for us. But in other instances, especially if you're a large organization, you're going to have, you know, maybe even hundreds of different types of pieces of equipment. And you got to be able to connect to it all, and it has to be easy. Any other thoughts on that, Dave?
Yeah, I would just say there's the 80%. What about the 20%? Well, the 20%, some of those customers either don't have the resources internally, or we'll go initially and do the initial setup and really use it as an opportunity to train them so that they can carry that across their other plants. And we also work with our customers and our partners to drive what are essentially consulting engagements around these opportunities to ensure they're getting as much value as possible out of the investment. But often the focus isn't on the connectivity part. It will be on something either supplemental to that drives value for that customer, or that's going to enable an accelerated deployment across the plant or the enterprise. So our whole focus is eliminating friction, reducing it in all aspects of our customers' business, and that's a big part of being able to enable our customers to realize value from their investments.
Yes, absolutely. Forgive me, we've got a number of questions, so I'm trying to answer them as fast as I can while we also take them on. But, you know, I think, you know, we're at the top of the hour. You know, I really appreciate the presentation, Dave. You know, I know that you come from a background where you've been on both sides of the equation. So, you know, of course you work here today, so there's a little bias, but, you know, I think that your presentation was really well rounded out and explored, you know, both sides of the coin very well. I hope that you all enjoyed it as well, because I certainly did. You know, again, if you have any questions or you'd want to learn more about the MachineMetrics platform and how we can work with your business, please don't hesitate to reach out. There's contact forms all over our website, or you can reach out to me directly, graham@machinemetrics.com, or you can reach out to dave.westrom@machinemetrics.com, or any of the other available ways to get to us. We will be sending this out as a recording, so do not worry, you'll have this, you know, at your leisure to watch again, which I certainly will want to do myself. And in the meantime, we hope that you all stay well and safe, and please join us for our next webinar in just a couple weeks, where we'll be taking on our ever popular State of the Industry series. So thanks again, Dave, and thanks to you all for joining us.